I am a professor in the Department of Environmental Sciences, Louisiana State University. And I do research and I teach, also do research on community resiliency, sustainability, and I have done research on Hurricane Katrina and on how what are the major factors that predict business to come back after Katrina. And so the general question that I research on has been what are the major factors that business, and also not just business, people make decisions to come back under a risky and uncertain environment. So in other words, my research has been focusing on decision making under uncertainty. Right after Katrina, I made free telephone survey for the whole New Orleans parish. And so the project includes 3 telephone survey in 3 time periods for the whole Orleans parish. And also I have a collaborator who lives in New Orleans, and what he did is right after Katrina he rode bicycle along 3 major streets and 3 major avenue in Orleans parish, and he rode it like every week to try to record what business have opened and where. And of course the 3 streets or 3 main avenues represent a rich neighborhood, a middle income neighborhood, and a poor income neighborhood. So we have what we call a 2-pronged approach to try to record the data, and then we develop economic models to actually derive the probabilities of given a business located in certain place within the city, and given the size of the business, given the characteristic of the business, and given the characteristic of the neighborhood, and given the flood depth of the business, we can produce the probability. We are not only working on what people commonly know, but also really quantify the probability in such a way that it's not only the depth of flooding, but also it depends on how what are your neighbors are doing. In other words, it's like if I have more neighbors that have opened in my neighborhood, it will affect whether I would return or not. So we not only inject the flood depth and other variable, but also what we call the spatial econometric variable to get into this. So that's one aspect of research that I'm doing. But then the other aspect, so I move on to also doing research with Professor Margaret Reams and other collaborators. And right now I'm developing models to try to measure community resilience. In other words, it's like if you have a community, how do you know this community is better prepared or have higher resiliency compared with another community? And the reason why measurement is so important is that so far there has not been a very commonly adopted indexes to show how you can compare one with another.
There comes a figure like 7, and 7 means this community is very resilient and is prepared to be back in business very soon.
Yes.
And you have a 3, and then you are very sensitive, and then you probably will take longer to get back in business.
Excellent. That's that's exactly what we are trying to do. Not only that we have a ranking like 3 or 7, which we don't have a 7, we just do it 1, 2, 3, 4 for this case, for so far what we develop. But also, once we know that a community is 4, then we have to look at why that community is 4. And then why the other community is 1. 4 means high resilience, 1 means low resilience. So that's the part that we really wanted to find out. And it's not only the 4 and 1 at one time scale. Hopefully we can find out, given what your characteristics of the communities are, can we predict, how you respond in the future? And also, what are whether the other communities can change the indicators in such a way to make them more resilient. During the Katrina, my research group and my colleagues have gone over to the Baton Rouge, command center and actually help how to produce the map on the flies, because the existing maps that people have at that point in time is just very complicated maps, and it's really hard for at that point in time, common people, volunteer people to come in and try to row a boat or fly the helicopter in order to do the rescuing work. So we are on the fly trying to produce very simple map. And I also mentioned that during my talk is that when the streets were flooded, you cannot use the map to see where things are. You will have to pretty much improvise and help using some local knowledge and put into the new simple map. It would be a crime for us meaning for academics, not to respond to the request for proposal. I mean, this is a request for proposal. It doesn't mean that you get funded, but at least you try. Well, I think you all did a very good job in terms of using a very strong engineering approach to stop the flooding. And from a resilience measurement point of view, we have a model, and you all now become so-called very resistant to the threat. But the point is that what will be the flood risk in 10, 20 years when you have climate change, sea level rise, and you have urban development like the land I was told that you all have subsiding. So it's very similar to what the problem that we have in Louisiana. I'm actually very impressed by what you have done, Holland, and this conference is that you all can develop a very focused and solutions. Not quite solution yet, but document that is identifying exactly what you plan on doing. Here back in America, I think we have a little bit more complexity because, well, the country is big, but also we have very different group, very different thinking. We have racial group mixing and different development. Those who are poor is very poor, and those are rich is very rich. So we have a much higher degree of disparity. So in fact, we need to learn from you all. How to start from the basic. And I think you all have a very good basic understanding and trying, and you all come together to really look at the solutions. And so that's something that we all need to learn or exchange views about that too.
Thank you very much.
Well, thank you. Okay.